Number 19. 2 times the absolute value of x minus 3 plus 1 equals 2. Alright, so subtract 1 from both sides. So you get 2, absolute value of x minus 3 equals 1. Divide both sides by 2, so you get absolute value of x minus 3 equals a half. Alright, so x minus 3 equals 1/2, or x minus 3 equals negative 1/2. Add 3 to both sides. X equals 3 plus 1/2. Get a common denominator. That would be the 2. So multiply 3 by 2 over 2. That's 6 halves. So you get 6 plus 1 all over 2, which is 7 halves. Alright. And over here you add 3 to both sides. X equals 3 minus 1/2. We already know that you can write 6 halves instead of a 3, so that's 6 minus 1 all over 2, and that's 5 halves. So the solution set is 5 halves, 7 halves. Number 21. Absolute value of 3x minus 2 equals negative 7. Alright. Now, the absolute value is always greater than or equal to 0. Alright, it's never negative. So this situation is impossible. Alright, so there is no solution. Alright, so DNE for does not exist, or you could write empty set like that, or you could write that symbol, which means no solution or empty set. And that's all there is to that one. You wish you had all your problems like this, right? Number 23. Absolute value of a third x plus 5 equals 14. So 1/3 x plus 5 equals 14, or 1/3 x plus 5 equals negative 14. Alright, so you can subtract 5 from both sides, so you got 1/3 x equals 14 minus 5, which is 9. Then you multiply both sides by 3, so 3 times a third is 1, so you get x equals 27. Okay, over here you got 1/3 x, subtract 5 from both sides and you get negative 19. Then you multiply both sides by 3, so you get x equals negative 57. So the solution set, negative 57, 27. Number 25. For the following exercises, find the x and y-intercepts of the graphs of each function. Alright, so we have f of x is equal to 2 times absolute value x plus 1 minus 10. So let's deal with the x-intercepts first. Alright, the x-intercept is where the graph crosses or touches the x-axis, and that's where y equals 0. The y values there equals 0. So if y equals f of x, which we're going to let that equal, then you set f of x equal to 0. Or same as setting y equal to 0. So what we have then is, what's f of x? 2. Absolute value of x plus 1 minus 10 equals 0. And then solve for x. 2 absolute value of x plus 1 equals 10. Divide both sides by 2. Absolute value of x plus 1 is equal to 5. And then we solve this absolute value equation using this setup here. Alright, so we have x plus 1 equals 5, or x plus 1 equals negative 5. And then subtract 1 from both sides, you get x equals 4. Or over here, subtract 1, you've got x equals negative 6. So again, y equals 0 at these points, so the two x-intercepts are 4, 0 and negative 6, 0. Alright, let's do the y-intercept. Alright, the y-intercept is where the graph touches or intersects with the y-axis, and that's where x equals 0. Alright, so you let x equals 0 in the function, or in other words, evaluate f of 0. And that'll give you your y-intercepts, or y-intercept. So f of 0 is equal to 2, absolute value. Let x equals 0 there. 0 plus 1 minus 10. And that's 2. Absolute value of 1 minus 10. And that's 2 times just positive 1, which is 2, minus 10, which is negative 8. Alright, so f of 0 equals negative 8. So that's where, in other words, x equals 0, y equals negative 8. So there's your y-intercept. Number 27. We have f of x is negative 3, absolute value, x minus 2, minus 1. We need to find the x and y intercepts. Okay, so x-intercept. That's where f of x equals 0. So we've got 3, or rather negative 3. Absolute value of x minus 2 minus 1 equals 0. Add 1 to both sides. Divide both sides by negative 3. And then solve this in the usual manner. Alright, well wait a minute. This makes our job a lot easier. The absolute value, once again, can never be negative, can never be less than 0. Alright, so absolute value of something is always greater than or equal to 0. So there is no solution for this. In other words, there are no x-intercepts. Alright, it doesn't touch the x-axis. Okay, All right. So how about the Y-intercept? Or intercepts. All right, so evaluate f of 0. That equals -3 times absolute value of 0 minus 2 minus 1. And that's -3 times absolute value of -2 minus 1. -3 times positive 2. Absolute value of -2 is positive 2 minus 1. So that's -6 minus 1, which is -7. So the y-intercept is 0, -7. All right. Number 29. For the following exercises, solve each inequality and write the solution in interval notation. So here we get into inequalities with absolute values, and we'll use either this or this setup. We've got absolute value of x minus 2 is greater than 10. So on this one, the capital X here, capital X represents x minus 2, and the k is 10. All right, so you set it up like this. The inequality is a strict inequality, so you don't write the equal part, but you still use that format. All right, so you've got x minus 2, that would be the x here, is less than -10. Or, and that means take the union after you're done, the x minus 2 is greater than 10, positive k there, so that's positive 10. X minus 2 is greater than 10. All right. So solve each of these separately. So add 2 to both sides. You got x is less than -8, and that's finished, that part. So this can be written as an interval, -infinity to -8, not including -8. And over here we've got add 2 to both sides, x is greater than 12. All right, so you can write that as an interval 12 to positive infinity, not including 12, and you're going to take, or means take the union. So you're going to take the union of these two intervals. Well, that's basically the answer. All right, this union that. Okay. Number 31. So we have absolute value 3x minus 4 less than or equal to 8. So that's basically this setup here. All right, so the capital X is the entire 3x minus 4, k is 8. All right, so you set up -8 less than or equal to the capital X, which is 3x minus 4 in this one, and that's less than or equal to positive k, which is 8. Now we solve it all together. So first thing, you're going to solve, try to isolate this, try to isolate the x in that middle part right there. So you're going to first add 4 to everything. Add 4 to everything. So plus 4, plus 4, plus 4. All right. So -8 plus 4 is -4. That's less than or equal to 3x, and then -4 plus 4 is 0, And then that's less than or equal to 8 plus 4 is 12. Now you divide everything by 3 to isolate the x. So negative 4 divided by 3 is negative 4/3. Less than or equal to 3x divided by 3 is just x. Less than or equal to 12 divided by 3 is 4. Alright, so that's basically it. Now all we have to do is write it as an interval. So we're using less than or equal to, so we're including these as endpoints in our interval. So it's a closed interval, and x is between negative 4/3 and 4 inclusive. And there's the answer. Number 33. We have absolute value of 3x minus 5 greater than or equal to 13. So 3x minus 5 is less than or equal to negative 13, or 3x minus 5 is greater than or equal to positive 13. Alright, so add 5 to both sides, so you get 3x is less than or equal to negative 8. Divide both sides by 3, so you get x is less than or equal to negative 8/3. So we have this interval negative infinity to negative 8/3, including that endpoint, like that. Alright. And then here you can add 5 to both sides, you get 3x is greater than or equal to 18. Divide both sides by 3, x is greater than or equal to 6. So you've got the interval including 6 to positive infinity. And or means take the union of those two answers, and there's your final solution. Number 35. Absolute value of 3/4 x minus 5 is greater than or equal to 7. So 3/4 x minus 5 is less than or equal to negative 7, or 3/4 x minus 5 is greater than or equal to positive 7. Alright, so add 5 to both sides on this one. 3/4 x is less than or equal to negative 2. And then to clear that fraction out of there, multiply both sides by the reciprocal of 3/4, which is 4/3. So that's 4/3 times 3/4 x is less than or equal to 4/3 times negative 2. So everything cancels out here, and that's just 1x, which is x, is less than or equal to negative 8/3. Alright, so what we have then is the interval negative infinity to negative 8/3, and including that. Alright, so over here, add 5 to both sides. 3/4 x is greater than or equal to 12. Again, multiply both sides by the reciprocal of 3/4 to clear the fraction. So we get x is greater than or equal to, note that the 3 cancels with the 12. So 3 goes into 3 once, goes into 12 4 times, and then you got 4 times 4 is 16. Alright. So x is greater than or equal to 16. So you've got this interval, 16, including 16, to positive infinity. And or again means union, so take the union of those two, and that would be the final result right there. Okay, number 37. For the following exercises, graph the absolute value function. Plot at least 5 points by hand for each graph. And here we're going to be using techniques from section 1, or the last section. What was that? That was 1.5, and that's transformation of functions. All right. So you need to go back to that if you haven't looked at that yet, and take a look and see how that's done. So I'm not going to spend too much time on the technique here, but we have for this one, y equals absolute value of x minus 1. So this 1 is next to the x minus a positive 1. So that means there's a right shift by 1 unit of this absolute value function, y equals absolute value of x. Shift it right by 1 unit. Since this is next to the x here, all you have to do is just add 1 to each of the x coordinates on the original absolute value function. So here's 5 points that we can transform on the original function, -2 to -2, 2. That's on y equals absolute value of x. Now you just add 1 to the x coordinate, all right, and that becomes -1, 2. Okay, and -1, 1 is on the original graph, y equals absolute value of x. So you add 1 to that x coordinate, and you get 0, 1. And 0, 0 is on the original graph. Add 1 to the x coordinate and you get 1, 0. And what else? We've got 1, 1. Add 1 to that x coordinate there and you get 2, 1. And let's do one more. 2, 2. Add 1 to the x coordinate and you get 3, 2. Alright. So you plot those points and connect the dots, get your V-shaped absolute value, and you should come up with this graph right here. Number 39. We have y equals absolute value of x plus 1. I'm going to subtract 1 from both sides, so I get y minus 1 equals absolute value of x. So the 1 next to the y tells you that there's a shift up or down. This is going to be up because it's y minus a positive 1. So it's going to shift up 1 unit. And what you can do is add 1 to each y coordinate on the original function, which is absolute value of x. Okay, so if you take, for example, -2, 2 on y equals absolute value of x, you add 1 to the y coordinate, you're going to get -2, 3. And if you get -1, 1 on the original function, add 1 to the y coordinate, you get -1, 2. Take 0, 0. add 1 to the y coordinate, get 0, 1. Add or take 1, 1, add 1 to the y coordinate, and you get 1, 2. And finally, if you take 2, 2, add 1 to the y coordinate, you get 2, 3. Alright, so you plot those points, these points on the right, connect them with solid lines and get your V-shaped absolute value shape, and you should get this graph right there. Number 41. For the following exercises, graph the given functions by hand. So we have y equals negative absolute value of x. So you divide both sides by negative 1, you get y divided by negative 1 equals absolute value of x. So think of this, negative 1 under the y tells you that there's a reflection going in the same direction as the y-axis. Alright? So it's a reflection across the x-axis. So you draw your absolute value function upside down, as it were. Alright? So you get the V shape, but the vertex of the V is pointing up instead of pointing down, and it's still at 0, 0, and there's no stretching or shrinking going on because the 1 absolute value here is 1. Alright, absolute value of negative 1 is 1, and so that doesn't cause any stretch or shrink in the, or change in the coordinates. It's just causing the y coordinates. You can think of multiplying the y coordinates in the original y equals absolute value of x. Multiply each y coordinate by negative 1, and all it does is change the sign of each y coordinate. It doesn't change its magnitude. Alright, so here's what you'll get right there. Number 43. We've got y equals negative absolute value x minus 3 minus 2. So first I'm going to subtract negative 2 from both sides, so you've got y minus negative 2 equals negative absolute value of x minus 3. And then divide, to get rid of that negative in front, divide both sides by negative 1. So you've got y minus negative 2 all over negative 1 equals absolute value of x minus 3. Alright, so this is a reflection of the original graph, which is y equals absolute value of x. This is causing a reflection across the x-axis, or in the same direction as the y-axis, since it's under the y here. This is causing a shift down 2 units, and this is causing a shift to the right 3 units. Alright, now you do the reflecting first and the stretching and shrinking first. If there was something going on over here as well, as far as stretching, shrinking, or reflecting, you could do either one of those first. Alright, but do those before you do the shifting. Alright, do the reflecting, the stretching, and the shrinking before the shifting. Alright, and then after we've reflected, you can take care of the shifts. You can do either one of those first, it doesn't matter. Alright, so let me take a representative point, for example 3, 3. That's on y equals absolute value of x. First you do this, you multiply the y coordinate by negative 1, so you get 3, negative 3. So there's your reflection across the x-axis. All right, 3, negative 3. And then you have a choice as to what you want to do first, either the right shift or the downshift. It doesn't matter. Let's do the downshift since we're on this side already. All right, so you subtract 2 from the y-coordinate right there. Subtract 2 from that y-coordinate, you get 3, negative 5. And then one more, you do this right shift. So you add 3 to the x-coordinate. Add 3 to the x-coordinate right there. So you get 6, negative 5. All right. So you can do that with, I would do the origin also 0, 0. That's the vertex of the V. You want to know where that goes. All right. Do that in a similar way as I've done here, and then pick another point and then transform that as well in the same way. And then you connect the 3 dots and you draw your lines, make that V shape on the absolute value graph, and you should get that as your result.